Hey guys, welcome back to the shop. I'm Joe. And it's a cold and rainy day here in Massachusetts. And that means we're going to make something. And this project, I'm sure that there's a ton of videos on YouTube about it. And the one that inspired me to do this was Crispy's Mark II ball turner using a boring head. I'm going to do some stuff a little different than what he did. He had some issues where he had made or he had used a different kind of tool post, and he had some clearance issues, and I'm going to make mine to take care of some of that stuff. And one of the things I'm going to use here is, I don't know if you've seen his video, but he made what he called a bearing block, and then he put it into his four-sided tool post. And what I'm going to use is a boring bar holder, which is a 3/4 inch diameter quick change tool post thing as my bearing block. And I've got my boring head here, and I got this big hunk of alloy tool steel, and I'm going to turn that into a ball turner. So stick with me, and we'll do some lathe work here. Okay, so the way this is going to work is this is going to fit into my tool post, and this boring head is going to fit right up on here like this and rotate like that. What I have to do is figure out how long to make this what I'll call the shaft here for screwing into this thing. This is a 1.5/18 thread. This is a piece of 2-inch bar. This OD of this boss right here is 2 inches. So it'll fit right up nice on here like that. Okay, I'm back. And well, I gotta tell you, my bandsaw blade has seen better days. One of the things about having a blade welder is if you get a blade and you strip some teeth off of it, you tend to just weld in another piece, and that bandsaw blade over there is made up of about 6 pieces, so it's a little hurting. But we got it done. 30 thousandths cut right there. I'm not going to push it any harder than that. Well, we got quite the pile of chips going here. I'm just pausing for a while to let this thing cool down. Usually I don't wear long sleeves when I'm working a lathe, but man, these things hurt when they hit you, so I do have my sweatshirt on today. I'm just being extra careful to not get near any rotating components. But yes, pretty brutal. Alright, this thing here is getting pretty close now, so I've taken my little hole gauge and I measured out the ID of this thing, and it's 754, and that means I got to take 64 thou off of this, and that's what we're going to do right now. So, alright, after a little polishing with some sandpaper and emery, we got this thing polished out to a nice bearing fit. Okay, so we got this mounted in a collet, and I'm starting to turn down the OD of this thing. I'm going to make a little 1/4 inch shoulder here for the little boss here. So it'll butt up like that, and then the rest of it I'm going to thread. That's a little better. Alright, that should be pretty close. Okay, set up for threading here. 18 threads per inch. Got my Iscart threading tool in here. Compound set at 30. And we're just going to do a little scratch pass here. So put on about 2 thou of a cut. Let her rip. Yep, that's 18. Yep, okay. Yep. Okay. Alright, I got a piece of scrap chucked up here and I've just been drilling it out. I got to get it out to 3/4 and I want a flat bottom hole. What I did off camera is I faced this off to 90 degrees so it would butt up against my bearing good. And I'm just going to go in 1.075 on the tailstock DRO, and that should get us to where we need to be. And what I've done is I've set up using an angle block. I've got my piece in a collet block here, 1 1/16. You got it mounted in the vise at a 30-degree angle. And I'm going to drill down. So what this is a shock rod. Had my shocks replaced a little while ago, and I always ask for the old shocks back because you can cut the rod out and it's real good steel. So I'm going to thread this, and I think our first project will be turning a ball for the end of that. We'll see what happens. I got a collet in here so I don't have to worry about the chuck catching me. I got it on a bolt, and I'm on center this way and this way. So let's see how this thing cuts. try it on this side. Too much, I guess. Well, I must say it's definitely more well behaved. I think I could probably improve this tool a little. Give it a little more relief on the back side. Yeah, this is sweet. Get rid of some of these stringy bastards. I think this might actually turn out to be a pretty good ball. Awesome. Once you get over the corners here, it becomes much easier. Now, I don't know if you noticed, but I prepared this by putting big chamfers on the ends, on the edges here, so I have to cut them. And doing this without a chuck on there is definitely a good thing. Do experiment with some chip breaker type cuts on some of these bits and see if I can get these chips to break. But yeah, this is awesome. It's gonna make a good one. think I got about 50 thousandths more to go, and this is going to be a sphere. Does make some decent bird's nests, I'll tell you. I don't know if this would do this with steel. It might break better. Yeah, that's almost a sphere. A couple more passes and we'll have it. Pretty sure all this tool spring is because of the bolt I'm using. It's hanging out there pretty good. It's only a 3/8 bolt. Almost there. We're just starting to touch the center. This might be it right here. No, one more pass. Oh yeah, baby. That's pretty cool. I'm betting that's about exactly 1.5 inches in diameter. So let's find out here. That is awesome. .475. So I started off with 1.5 inches in diameter. 1.478 actually. But wow, yeah. That worked out pretty good. Not bad for Okay, so what have we learned here? We have learned that you have to do this by changing the radius of the cutter. You can't move the cross slide or the saddle, and it has to be exactly on center in both axes. In other words, it has to be on center this way, and it has to be on center this way, so that it'll sweep across the whole thing. As far as the cutter goes, that's all I had. Now, I think if I was going to do this over again, I'd kind of tilt this down a little, or grind some relief on the back of this so that it wouldn't rub, because I could tell, like right at the very top of this ball, there was a very slight bit of rubbing going on with the back side. So you gotta put some relief on there. Okay, so there it is. Pretty nice aluminum ball. I think got to experiment a little bit with some tool bits. John Mills was using a broken milling cutter. Chris was using a piece of high-speed steel. What I have in here is a piece of 3/16 carbide. So anyways, yeah, success. Thanks for watching.